No, like, not in the code. It's because we have a midterm, so I just wanna go over the concept in general.
Oh, I see. Okay,
Yeah.
makes sense. Um, so from the, I'll come because we are already looking into the code.
Okay.
I'll just show you
Yeah.
3 lines of code and then there itself I'll try to explain you the concept as well,
Okay.
because there are plenty of videos explaining about binary heaps theoretically with diagrams, beautiful diagrams. But it's not that difficult at all if you understand these 3 lines. It's all about, see, in general, regarding the confusion to the students about heaps is we visualize heap as a tree. And usually any tree data structure, we learned that tree can be constructed using similar to doubly linked list. If it is a binary tree, we use the notion of creating a tree using, uh, I'll type here, something like that, class or struct. And then we always write code around this structure, right? So suppose the data here is data, or maybe in this case, we may use the concept of time. It can be arrival or departure. For now, I'll use time. This is something in our mind, we get it when we speak about trees, but heaps are not this. Heap is a simple data structure like this. That's the confusion. Everyone, you know, feels heap is kind of mysterious concept. That's why I would like to explain you. Heap is, visualize heap like this, but the operations are similar to this one. However, you never deal with pointers in this heap data structure implementation. Rather, you use a concept of arrays. The challenge with this array is, especially in C++C, these are static, right? Because the size is fixed, either like this or maybe first time when you are defining it in a class or anywhere. I think so, but whenever you use the operator, but still in both the cases, the size is fixed. So to avoid this, you have a concept of dynamic array. The dynamic array is called vector or list in, I mean, understand that they internally use array only, but the size is all automatically increased based on the number of insertions. So as a developer, we don't need to take care of the size, overflows, all that stuff. However, still we deal with the indexes. Okay, so that is something. So you need to focus more on the array and indexes when you were speaking about heap. But heap is going to tell you that you can visualize a tree, even you can construct a tree using concept of arrays. That's all about this program and the whole concept of heaps. But unfortunately, we start learning about heaps after learning tree using this structure, binary trees, binary structure, binary search trees, and then the balanced tree or AVL trees. Once we learn all these, which follow this pattern, later our professors, you know, introduce the concept of heap. That makes our
Mm.
mind confused. Whereas if you talk about heaps, when you are learning about quick sort, merge sort, bubble sort, Heap is also similar sort if you use it for sorting, but it can also be used for prioritization in the real world, like queues, priority queues implementation. So at least when you are learning about stacks and queues, that would be the right time to talk about heaps. So when you start learning about pointer based tree concepts, then an array based tree is completely, confusing to the students. That's the reason why everyone feels heapify operation is difficult, whether it is for
Mhm.
insertion or deletion. But it's pretty simple. That's what we are going to cover in next 5 to 10 minutes. So what you should not do, heap is not this kind of tree, but you will still achieve the same result using an array. But that array is also dynamic one. So in C++, vector is already available to provide this dynamic array concept. Okay, that's what I have used in my code. Now, let's go and play with this. So we have built a heap of type, any type, but in our program, it is a type event. An event can be, this is beautiful concept. We can say polymorphism is available here. Event is one class or one type, but this class is providing you two kinds of operations. It can be either arrival event or departure event. Okay, arrival events will have, where is the input file? This one. These are the arrival events. Arrival time and the transaction time. So when a customer comes to Tim Hortons, say like this is Tim Hortons queue, that customer ordered coffee, which takes 5 minutes. Second customer came at 2 o'clock, ordered again coffee, 5 minutes. 4 o'clock, 5 minutes. 4 p.m. These were AM.
Mhm.
Sorry, not 4, 8 p.m. 5 minutes. And this is 12 p.m. 5 minutes. Sorry, 10 p.m. This is 12 a.m. This is 2 a.m. So it's continuing, but you could put it to 24-hour clock, or you can do whatever you want, or maybe minute. You can say 26 minute, 28 minute, 30th minute, and this is after 1.5 hour. And so these are just arrival times of that particular session, and these are all the time to process the order by the customer. Probably here this guy might have asked for some donut or Timbits. But these are all asking for coffee, so which takes a little while. Now, arrival event needs to be stored with these two variables. One is time, arrival time, second one is transaction time. But departure event doesn't need two, just one is enough. When was it departure? Or which event was departure? That's it. So departure is the outcome of arrival, right? So you have 10 arrivals, then the number of departures should be 10. So departure is just an outcome of arrival. So the first test case is number of arrivals should be equal to number of departures in our program. We did it. And always arrival should come followed by departures. This is second. Anyway, now since we are talking about the queue, to, to store this input, we can use three variables or combine them in a single thing called event. So this is already defined by your problem statement. Store like this only. That's why
Mhm.
you have no choice. We should not modify this class. We
Yeah.
should store like this. So that's why we are using event. But heap needs, if you go to the heap and the insertion of a heap, we need what we call comparison. Which one to store first in the order of storage? So we need to do a comparison that is called priority. So always remember heap requires comparison. So here we are doing the comparison between two events. So whenever a new event is coming, this is event. Event means arrival event initially, but it can be departure too. So we will be doing that. But initially, whenever an event is coming like this, okay, so we are creating equal number of events. Okay, whenever an event is coming through, oh, we are trying to insert, it can be arrival or departure, but this is where we are passing that object. The object is of type event. But the question is, C++ doesn't know how to compare two objects using less than symbol. Because what is the purpose of this symbol? It usually compares two numeric values
Mm.
or characters. Even a character is internally, it's ASCII code. So still it is a numeric value. A character doesn't do the comparison of two objects. Now, how should I compare two objects in C++? There is a
Um,
concept called operator overloading.
okay.
So this operator is overloaded to compare two objects. What type of objects? They can be any events, arrival or departure. I have to compare. Now tell me, how can you compare two events? Like two customers, how do you compare? If you are a storekeeper and you have to serve their orders, and both the
Like
customers have come, but their orders were created through online. Now, how do you compare which one to take first?
whichever one was ordered first
Right. That is nothing but
using
time,
priority queue.
arrival time. Yeah. But while building the priority queue, our comparison factor is
Mm.
time,
This
arrival time.
time.
Yeah. Where is it stored? It is being stored in this event class. This is the time. And we need to compare means we need to write that operator overloading code. This is the code.
What is the overloading symbol?
This is operator with any operator name is called operator overloading. It means
Okay.
you can use that
What is
operator.
the double less than sign?
This one, sorry,
No. But I remember like seeing in my notes that there was like a double less than sign or double greater than sign.
they are shift operators,
Shift.
left
Okay.
shift and right shift. But here
Okay.
you can use any symbol, it doesn't matter. But as
Okay.
long as if you use the keyword operator, that is going to help you to do two works.
Okay.
Okay, that is called operator, this one. So that's something we already should have learned during our C++ course, but not, maybe we can revise that. However, this code, you don't need to really care much. You just understand this is important logic. Time is less than right hand side dot gets time. This one is left hand side time. This one is right hand side's time. What is left hand and right hand side? These two elements. Data is a vector because this is the data and it is defined as a vector. Oh, vector in the header file. Yeah, this is data. This is defined as a vector, which I already told. Vector means a dynamic array. Imagine like that. It is an array with unlimited elements. So you don't need to care about the size. If you create an array, you have another headache while creating, when a memory is overflowing. But vector
Mm.
takes care for you. So it is a utility. Now, this was defined in binary heap.header. And then in our program, when we are inserting, I'm just inserting pushback means push at the end. Add always any new element into the heap should be added here. Understand? So far?
Yeah.
Okay, cool. And then what we are doing, we're just doing comparison between index and index minus 1 by 2. This is something you have asked me. I need to know in theory how the insertion works. So
Mhm.
to understand that, I'll show you through a simple tree, uh, you know, example. Say like in simulator input one. No, I cannot do this horizontally unless I have Sublime, but I can type it 1 to 4, 20, 22, 24, 1 to 4, and then 20 to 30. Let's start with this. 1, 2, 4, and then 20, 22, 24, 26, 28, 30, and 88, and then 93, I feel. No, 88, that's it. These are the arrival times of customers. Now we need to store this in a heap, right? So since we take always the lowest size value, luckily these are already sorted order, no worries. However, sometimes they can be randomly, the customers can visit randomly, but still online orders will always be pretty much like this. So when you are constructing this kind of heap, it's pretty easy, right? One is the root node, and then 2 has come. 2 is the left child, and then 4 has come. 4 is the right child. What is the property of a heap, min heap?
Um, like what do you mean property? Has to be a binary search tree first?
That's correct, but there is another important property is there about heaps. That is
Minimum is that like the root has to be the smallest element?
correct. Always root should be smaller than its children.
Yeah.
And it should continue throughout the tree structure. That's why this is a heap tree. This is how the heap is being built. And the third one is it should be near complete binary tree. Means always left and right child should have values and except the last level. So that should be kind of balanced binary tree near.
Mm.
Yes, I mean, it should follow AVL tree properties too. 28, 30, and then 88 has come. 88 is the left child of 22. You can understand, right? I did not draw the vertical lines. So this
Yeah.
is the root node at level 0. And this one, I would say index. You can store root node at index 0. And then its index value is no guess, 1.
For binary heap, it doesn't have to be in binary search tree?
That's what I told at first. It shouldn't be.
Okay.
You should use the array data structure.
Okay, okay.
So that's why, right? Your professor shouldn't teach you about trees. It should be covered while you are learning
Yeah.
about searching, sorting. That's why whenever you imagine with this diagram, in your mind, you will imagine left pointer and right pointer. No,
Yeah.
please understand. it is pretty small array. And indexes are starting, root is going to be starting with 0, left one is 1, right is 2, and continue like this.
Okay.
Its index is 3. That's why my students usually don't like me, because I don't teach what your professors teach. That my style is different. So I will make them much more confused at first, but once you catch this, you will never forget it
Yeah.
in the interviews or anywhere in the work also or job. But as a student, it would be overkill, because your professor taught you something, books
And
teach
it's
you
different.
something,
Yeah.
and I teach something, but all are same, just a little difference, variations. Uh, it's like same Rishita with different hairstyles or different costumes. Yeah. Cool. So now let's come to index number 3, 4, 5, 6, 7, 8, and 9. This is how you need to represent in a tree structure diagram. But actually in the array, this is how it stores.
Hmm.
These are the these are the data or events. I would say events data. These are the, it's relevant, I would say vector indexes, but internally there are arrays. Is it the same? Both are same,
Yeah.
right? But in the interview, you need to explain both. Interview or even to
Okay.
your professor, anywhere, anyone asks you, in your mind, this should be printed, Rishi. This is what all about heaps. If you understand this, you will never forget it throughout your life. If you don't, if you don't present like this, I bet you 99% of the YouTube videos or anywhere in the books, they represent it like a tree diagram. The
Yeah.
challenge is, the challenge is you imagine it like that one, which I have explained you. Gone. We're gone in the interview. Never ever do this for heap.
Okay.
Heap, same as trees, same as stacks, queues, or regular searching, sorting. Heap also a linear kind of structure where arrays are good enough. Unfortunately, it it it's like mix. You will imagine like a tree, but it's not a tree. Now let's come back to the core insertion part. So now tell me, it's already a heap tree, no worries. But suppose online orders are like this, but this customer, number 88, has come at beginning. And this customer has come at the very end to the physical store for pickup.
Mhm.
But as a storekeeper in the computer, you have to build a heap tree and pick up the root element. So at root one is there, one is there. Okay, good. But this one is not here, right?
Yeah.
So what should you do? You should do heapify. Heapify means,
Okay.
hey boy, Your number is not in the priority. There are other gentlemen available, so please go to the back. That is what heapify. Heapify means arrange elements in this order, heap order. So 88 is not following this concept. So where is its index right now? Here it is. And 2 is here.
Mhm.
This is what, right? The current system setup. Now
Yeah.
let us do heapify. If I do this, you will understand this logic. Okay. So I'll do here. I'll copy paste the same tree. Now 88 is greater than 1, all good. 4 is greater than 1. So 2 passes are good. Level 1 is good, level 2 is good so far.
Mhm.
Now let's come to level 3. 88's left child 20. 20 is smaller than 88. Okay. Now you should do swapping. It can be done in both the ways. You can compare either these two, one with 3 or even one with 4. Your choice. So in this program, I have done the comparison between index, which is root node. Say like in this case, root is 88, means index 1. And, or maybe if you take it in this way also, you can do, I was doing reverse way, but you can do either way. So here I have done through reverse way. So this, say like this one is 3, index 3, or 4. 4,
So heapify starts from the topmost or bottommost?
you can do it either way. But while I'm
Okay.
explaining, I usually do it from top. But, you know, I did it in the reverse here because I came from, so index has started with this, right? Size -1.
Mhm.
So it means it is coming from the bottommost. Ideally,
Okay, yeah.
it is common practice to start from end and then keep adjusting from end to beginning. But I was just as a habit, I wanted to do it from top. So let us start from, as per this code, let us start from the bottommost. What is the size? 10 minus 1, 9.
10.
9 is the index. Index is
Yeah.
9. So I'm comparing 9 with 9 minus 1, 8 divided by 2, 4.
4.
9 and 4. What is there in 9? Value 2. And what is there in 4? Index 4, 22.
22.
So I'm comparing 2 with 22. These two are not making sense. So I need to
Yeah.
do a swap. That's what it is saying, right? Just do a swap.
Yeah. But in the code, why are you dividing by 2? To get like each side?
Uh, Very good, wonderful question. This is definitely being asked by interviewer, whatever you asked me,
Mm.
because that's the whole point here. If you see the pattern, Rishita, in this, what is the root node of 22? What is the parent node of 22?
80, 88.
No, in this structure, 88.
Mm.
Yes. And what to say? For 22, yeah. And how about 30? What is the parent node of 30?
20.
Right. So how did you say?
Based on, yeah,
So
diagram.
just do the logarithm. Log 8 is 3, 2 cube.
Oh, okay.
Okay. So you can either use log or just to divide it by 2. Index minus 1 by 2. So
Okay.
if you see the pattern, 8 minus 1 by 2,
So is
7
that the
by 2.
time efficient?
Yes. So 8 minus 1 by 2, 8 minus 1 is 7, by 2 is 3. If you round it off, because it is integer index. Same way, 7 minus 1 by 2, 6 by 2 is 3. So always the formula for root node is n minus 1 by 2, or simply
Okay.
log
Prepare.
index.
Okay.
So that's why we used this concept. So we are comparing root with, element with the root, and then if they're not same, we need to do. So what I did doesn't work like this, because you should not insert anything unless this order is proper. So if I need to insert something, I should take you like this. But for now, since we already in middle, I'll explain you. So 2 will be comparing with this. 2 and 22 will be swapped, just for your sake. But ideally it doesn't work like that. While inserting 88, 88 usually comes here, and then it will be
Okay.
comparing. But rather, I'll help you in another way. The reason is I don't want to confuse you more. Say like another customer has come. This is already built. To explain that code, in the index 10, there is an element with 33 has come, or maybe just 13 has come to the index 10. Usually we should insert that at the very bottom. This is the bottom. Okay. And the value is 13, 13. So 13 has come, and the value is index 10. Now 13 will be comparing with 22. If both are not following heap property, what we should do?
Swap.
Heapify, swap. Heapify means swap. 13, 22. This is first one. And then you should continue doing it, right? So we have compared this, similarly compare this, 88 and 13. Makes sense. 30, 20, 28, 20. So this whole level is good. Now go up, reduce the index, and compare 13 with 2. Makes sense? Yes, all
Yes.
good. 2 with 1, all good. So just one swap has taken care. Now a new element has come, and its value is 5. Just 5. What should I do? Or maybe 3. What should I do? Compare 3 with
Compare with
24
24.
and just do the swap. And again,
And then
3 with 4. Do a swap. And then 3 with 1. It's all right. So these indexes will be ordered like that.
okay.
Okay, so 3 will be coming here, and everything else will be, not everything else, but only the relevant hierarchy will be changed. Not everything, it doesn't shift completely. It will be arranged like this. Okay.
Yeah.
All right. So this is how you can, but it is not completely sorted. See, 1, 2, 3, 20, 13,
Yeah.
4, 26. So that's the reason some more better algorithms are there, which could even put this also in right order. But the goal of heap is not taking care of this order, only this value. To whom I should immediately serve, number 1. After that, I need to reshuffle the right person with the right person. 2 or 3, maybe you can pick up and then do the same operations. That is what heapification will happen. The reason is heap doesn't care about the rest as long as they are smaller than the root, except the root node, because you always need the root node to be picked up and then served to that customer. And then the tree should be arranging in such a way that 2 should be the root node, and then 3 should be root node, and then 4 should be root node, and it follows
Mm,
that. Okay. You don't need to care about the rest of the whole queue because there can be here and there customers could extract. But my goal
okay.
is always the immediate customer should be the first priority one. Keep that in mind and perform the same in the interview, and you will get the offer letter.
Okay.
Okay. I would like to put heap concept at first in my interview chapters.